Hey there. Last week at Rivian's AI and Autonomy Day, they were giving really cool demos of their point-to-point self-driving system. And as I tend to do, I think it's time for us to pick it apart. So let's go. Chances are, if you're watching this video, you've probably already seen a whole bunch of other videos covering this demo drive that they did. And honestly, the demo drive that I went on was rather uneventful and kind of boring, which is a great thing because uneventful means uneventful. But I think there's a lot that we can learn by diving a little bit deeper and pixel peeping, so to speak. I noticed quite a few interesting little nuances about the demo drive and the software that they were running that nobody's talking about. So let's talk about some of my observations here. Now, before I dive into it, it is worth mentioning, as always, when I do this kind of content, this is all just based on my observations, knowledge, and assumptions, and none of it has been explicitly confirmed by Rivian, so I may not get everything right. So if you noticed anything like this, feel free to chime in. If you feel like I got something wrong, chime in below, let me know. First, I want to talk about the pre-production engineering software that they have loaded on these demo vehicles. Then I want to talk about the driving model itself and some interesting behaviors I noticed with that. And then we'll finish up talking about what's to come with this point-to-point self-driving system. As a quick side note, if you find this information useful, interesting, or entertaining, and you're thinking about buying a Rivian, use my referral code down below. It'll give you up to 500 points on the Rivian Gear Shop to buy some cool accessories, plus you get free charging. Win, win, win. Before I get into my observations, just a few quick things about how my demo drive went personally. Like I said, honestly, it was pretty drama-free. It was very smooth, very controlled. It was a very passive driver. It drove rather slowly, but it felt very smooth and very confident. There were only 2 disengagements on my drive. The first disengagement was when there were a couple of cars in front of us that ran the red light. And because it saw the 2 cars in front of us run the red light, it thought that it was allowed to run the red light too. I guess I can see how that might happen in the world of AI, but the driver had to disengage so it didn't make a 3rd car running the red light. The second disengagement was when we were approaching a traffic light that had a long line of cars behind it, and a lot of cars were getting over to the right into the right turn lane. And that's where we needed to go for our route as well. But the system wasn't really quite sure if it was allowed to get over yet, and it was a little bit unsure. And so our driver had to disengage and help it move over. But those are the only 2 disengagements on my drive. And honestly, that's very impressive. And granted, it was a curated course. Every single one of us went on exactly the same route. But for such an early demo, I was honestly impressed with how well Rivian did with that. Okay, let's dive into the pixel peeping. So starting off with the pre-production software, the first thing that I noticed right off the bat is there are no engagement or disengagement sounds on this version of the software.
Okay, so this is
just gonna manually touch a little bit here.
When the system was turned on, completely silent, unlike the sound that we're used to hearing when we turn on highway assist. There could be a couple of reasons for them muting the engagement and disengagement sounds. One of them could be that when they're doing their test drives, it just gets fatiguing hearing those sounds over and over and over again as they're testing on the streets of Palo Alto. What I think is probably more likely is for this specific build that they made for the press event, they probably didn't want the system calling attention to itself. This was for the tech community and the Tesla community at large to show off what they've been doing. And so they didn't want the system calling attention to itself for good or for bad. You know, hey, I'm engaging now, or hey, I made a mistake, I need to disengage now, things like that. Now, to be fair, the safety drivers that Rivian had in the vehicles were explicitly calling out every single time they engaged or disengaged the system. So it's not like they were trying to hide when the system made a mistake. Every time it did make a mistake, it was very well known, and we were verbally told, hey, I'm disengaging the system to help it with this thing now. Okay, quick little side note. I was going through and editing, and I realized there was something I forgot to mention. You may have seen it in that last clip there, but co-steer is acting a little bit differently on this drive. On the production version that we have on Highway Assist, with co-steer, you can tug on the steering wheel a little bit to help kind of guide it where you want to go. But if you pull above a certain point or pull past a certain point, it will disengage the system. It seems that on this engineering demo build, that co-steer just lets you tug as hard as you want and pull as much as you want, and the system stays engaged, which is interesting. So it looked like in this last clip, the steering wheel was kind of fighting the driver a little bit, and she actually had to push the stalk to disengage the system. So I don't know that that necessarily means anything. It's just a setting that they had for the engineering build, but interesting to see nonetheless. Another interesting element to look at was the UI that was on the screen. So at this point, we've all seen screenshots of the upcoming release of universal hands-free in the December update coming to owner vehicles. The UI that was running in the vehicle was an earlier build of the software that we will be getting soon. So it has some of those elements of the universal hands-free. For example, the little drive style icon that lets you choose between mild, medium, and spicy drive styles. It had the speed limit. But interestingly, even though these UI elements were shown on the screen, none of them were actually active. We were told that for this specific engineering build, the system actually wasn't adhering to the set speed. It was just deciding how fast to drive on its own. And honestly, I was perfectly happy with how fast it was driving. It was very conservative, very safe, but I didn't feel displeased with the speed at all. And obviously for a production build, this would not be the case. You would absolutely have more control over the speed, whether that's a specific set speed, just like cruise control, or whether it's more like Tesla, where it sort of matches the driving style between mild, medium, and spicy. I'm not sure, but just engineering build things. That's not something that would make it into our builds. Another interesting thing that I noticed, and I noticed this mostly when I was watching Bearded Tesla's video, it doesn't look like the system was actually following Google Maps at all. They'd had Google Maps running on the center display as we were driving, but I think that they were doing that just for the benefit of the passengers so we could see the route that we were going to take. It seemed that for whatever engineering build they set up specifically for this demo drive, they hard-coded in the route to the back end as an input to the system, rather than tying the system directly to Google Maps. And honestly, that makes a lot of sense to me because this was an engineering build that was made specifically for 2 days worth of demos on a specific route that they're going to be driving over and over again. That's a lot of time and overhead to connect it to the infotainment system's nav, which goes through Google and all of that routing. Obviously, for a production build that would go out to consumers' vehicles, they would bother hooking those wires up, so to speak. But for an engineering demo, completely unnecessary. So it just had its own route suggestion input to the model in the back end. This is what I'm assuming anyway. The reason that I say this from Bearded Tesla's video specifically is I noticed that the vehicle started driving and following the route correctly before the safety driver actually hit go on the Google Maps navigation. And on top of that, at one point, the Google Maps navigation actually made a weird right turn and then immediate U-turn to go back on the same route. And the vehicle followed the more logical direct route of just turning left immediately. So it seems that it was just kind of ignoring Google. And again, makes perfect sense. I don't mind that. Just interesting to observe. Another interesting thing to observe was the fact that the visualizations on the screen really didn't show any kind of traffic control. No stoplights, no stop signs. It didn't show the brake lights and turn signals of other cars. And that doesn't mean that the system isn't seeing those things. That just means that the front-end UI hasn't been developed for that yet, which makes perfect sense because up to this point, none of the functionality that we have in our vehicles really relies on stoplights or brake lights of vehicles in front of us. Well, I don't know, maybe highway assist could benefit from that. But you definitely can see where they're going because the 3D clay models that they show on the driver's display have very clear cutouts for vehicle tail lights and turn signals. So one can assume that at some future date, they will add the functionality in to be able to see those things. But to be clear, it definitely was seeing red lights. And this is where we're going to start talking about the model specifically and how the model was trained. One interesting thing that I learned as I was driving around with the engineer is that the system early on actually drove incredibly fast, which makes sense because Rivians are incredibly high performance vehicles and people like to take advantage of that performance quite often. And so when it's trained on customer data on people that are actually driving Rivians around, there's a high probability that people are driving around maybe a bit quicker than they should. So early versions of the system were actually incredibly fast. They would just whip around. So with the training data, they specifically had to find more moderated driving scenarios to train the system with, at least for the model that they were using on this one. And I would imagine that that also plays into the mild driving style on universal hands-free. More testing on that one to come later. Another interesting observation that I made is that the system was not making right turns on red. And this we were explicitly told. But what was interesting about it is in a few of the demo drives with a few other people, this didn't happen on mine, but on a few other people's demo drives, it actually did make a right turn on red, even though it was programmed to not do that. So clearly somewhere in the training data, it exists for the vehicle to stop and make a right turn on red. For the purposes of this event, I think that they specifically tried to make it not do that just for safety. It's an early build. They want to make sure that they have high confidence in these cross-traffic situations, and maybe they just don't have that confidence yet because it requires more training and more fine-tuning of the model. One interesting thing, though, is they were trying to flex the ability to control what the model does, so they can specifically turn on and turn off specific behaviors with the neural net. And it seems that it was mostly successful, but not entirely successful. So this is one of those things that definitely will require some more work before the official release. And as a quick aside, that's one of the interesting things about these neural nets. Machine learning is just kind of a wild animal. It sort of thinks on its own. And so it's not about just like flipping a switch on or off. It's about guiding the neural net to have the outcome that you want, which is definitely easier said than done. And they're definitely making great progress. Still some progress to be made, but they're doing pretty well with that. It was interesting to see a couple of things that the system couldn't do. Merges seemed a little bit difficult for it. Just gauging other vehicles moving in and out and how to cut into a merge in the lane. On my specific drive, it didn't have any trouble with it, but I did see other people's drives where it did have problems with that. And then the other thing that it still seemed to lack a little bit of awareness of is pedestrians, and that's a big one. And both of these things are certain to come soon. It already recognizes pedestrians and displays them on the driver's display in current software versions. And so it's not far-fetched to say that in the future, it will be able to understand how to react to that better because it already knows that they're there. As far as merging, I also don't feel like that's far-fetched to see fairly soon them getting that functionality a little bit more honed in, because we already see elements of that same kind of driving in lane changes on the highway. When you turn on your turn signal, if it isn't immediately open for the vehicle to get over, it will either speed up or slow down to try and find a place to fit into traffic. And it's a lot of the same kind of driving that you would have to do for a merge. So I don't think that's too far-fetched that that would come along the way. A couple of other interesting things that I learned about the training as they were driving around is they said that while positive reinforcement is incredibly helpful, for example, saying, ooh, this is good behavior, do this. It's also sometimes helpful to have some negative reinforcement too. An example that they gave is that they found it actually helped the model to drive a little bit better if they fed in scenarios from drivers on the road with actual R1 vehicles where the automatic emergency braking system had to kick in because the driver was texting or not paying attention. And by feeding not a ton, but they said at least a few of these bad driving scenarios into the system and saying, do not do this, that actually helped it drive a little bit better. So it doesn't get to the point where it would need the automatic emergency braking, because all of the safety features are actually running on the same model, whether it's blind spot monitoring, whether it's cross traffic warning, whether it's the automatic emergency braking, the matrix headlights even, all of these things run off of the same self-driving model, which is kind of cool. Another really cool thing that was noticeable in this driving model was its behavior around speed bumps. And they actually pointed this out specifically when we went near a speed bump, that it slowed down and very gracefully went over it. And it's not like they had a specific line of code that said, if see speed bump, slow down here. Instead, this is something that is trained into the AI model. They just find various scenarios in training data where a customer slowed down for a speed bump, went over it, and sped back up. And after feeding a number of these scenarios in, then it understood, oh, when I see a speed bump, I can slow down for it and move forward. No hard-coded rules that say you have to do that, just teaching it how to drive, which is very cool. On the note of training data, One interesting thing that they were noting is they have an immense amount of data coming in. And granted, I do a lot more driving than most people do, but I've noticed that my vehicle uploads between 200 and 300 gigabytes a month of driving data to help train this AI model. And it sounds like pretty soon they're actually going to start getting a little bit more targeted with how they're collecting data. Up to this point, it's been things like, oh, hey, we want to learn more about how turn signals are used. So can you collect data about when people turn on turn signals and go around a corner? And so then anytime someone would turn on a turn signal and turn around a corner, that data would be triggered to be collected and sent back to Rivian for training. And that's how they've been approaching it up to this point, and they've gotten a ton. But now that they've gotten a large volume of training data, the most of which is just boring, driving down the road stuff, they're going to start looking for fewer but more targeted examples. And we can see this start from the update coming out a little bit later this month. They've already told us that in this update, they're going to start collecting more data from the start and the end of the drive because they want to target low-speed driving scenarios, aka parking. As it stands right now, the privacy policy says that they can't collect the first 3 minutes or the last 3 minutes of the drive, which is unfortunately exactly when parking happens, and the vehicle can't learn to park if there's no data on parking. So now they're adjusting it so that it will collect the first 3 minutes and the last 3 minutes of the drive if you're not in your saved home or work locations. That way you can still have privacy at your home and your work, but the system can learn how to park by seeing how this happens in parking lots and things like that. And they've told us explicitly this is on their roadmap. So there's definitely a lot of training to be done, and we can expect Rivian to start honing in on these more specific scenarios as they enhance this functionality. So what's to come with this point-to-point self-driving system? Well, a good thing that we know is that Gen 2 vehicles are definitely capable of running the system. And there's still headroom to spare on the Gen 2 compute platform. So even though Gen 3 is around the corner, Gen 2 definitely still has more to give. I don't have a crystal ball, I can't tell the future, but it seems all but certain that Gen 2 vehicles will have this point-to-point self-driving system, which is extremely exciting. But before we get there, there are still some definite improvements that need to be made to the large driving model. It needs to have a little bit more honed in sense of how to handle, for example, what we saw in merges or stoplights and pedestrians. And as universal hands-free rolls out to customers' vehicles and people begin actually using it, I think that we're going to see a lot of improvements to the driving model. Even if the specific functionality of stoplights and stop signs and things like that is turned off, I think we'll see this system get a lot smarter. As the large driving model gets closer to production ready, I suspect we'll see a lot more features show up as well. We might see parking come into play. We might see more stop sign recognition and stoplight recognition. For example, we might hear a go chime when the light turns green instead of just a go chime when the vehicle in front of you drives away. We might start seeing taillights and turn signals on the driver's display. I think that we'll slowly start seeing more and more features show up until at some point, hopefully next year, we get an actual production-ready version of this point-to-point self-driving system. This is all right now very reminiscent of Tesla's FSD 12, which was, may I remind you, not even 2 years ago that came out with. That's when Tesla first came out with their end-to-end AI-based self-driving system. They completely discarded all of the hard-coded rules-based driving, and it was all end-to-end neural net. And that's where Rivian is right now. There's certainly a lot of ground to make up. FSD 14 is quite impressive, but they're definitely doing some really nice things with their point-to-point self-driving system. And I think that there's a lot of promise. Okay. Okay, first let's... Hey, look at me. I made a mistake. Maybe during their...